In this example, we're going to continue working on graphing systems and finding out what our solution to a system is. And so our focus needs to be on the different ways we can graph linear equations. Input-output table, slope-intercept form, intercepts. And again, any of them will work. You need to pick the one that you think is easiest or that you're most comfortable with. So let's start with this right here. Let's start with 3x plus y equals -3. Okay? And again, when I draw that line, I'm drawing a representation of all the solutions, all the pairings of x and y values that make this true. When we're working with the system here, we're looking for the ordered pair that makes them both true. So again, like I told you before, like there's a 1 here. If I look at the coefficients of x and y, and 1 and 3, like go into -3 evenly, no decimals or fractions, I'm probably going to look at doing intercepts. So that's what I'm going to do first. I am going to plug in 0 for x, and then I'll plug in 0 for y. So right here, I'm going to go 3 times 0 plus y equals -3. Just substituting it in and solving. 3 times 0 is 0. 0 plus y isn't going to change anything. It's just going to be y equals -3. So again, at our y-axis, we can think of our intercepts at -3, or you can think of this as the ordered pair 0, -3. Okay? I'm going to actually erase it off because I need some time here, okay? If you put it there, don't worry. All right, now I'm going to put 0 in for y, and I'm going to go 3 times x plus my y, which is 0, equals -3. Again, adding 0 on doesn't do anything, so I'm left with 3x equals -3, and then I'm going to divide both sides by 3, and I'm going to get x equals -1. So this is my ordered pair, -1, 0, or I can go on my x-axis to -1 and put a dot. And then I'm going to draw a nice long line through them. Definitely use a straight edge. You do not want to just freehand this because you're just not going to get the right spot. Remember, we're looking for a point where they're intersecting. So we really want to make sure that we get the right line. Okay? Now, I want to show you this. Hopefully. Another way we could do this problem is to put it in slope-intercept form and solve, meaning solve for y. So if I'm solving for y, I have to get rid of the 3x, so I'm going to subtract 3x from each side. That gives me 0. Again, adding 0 on doesn't do anything. I get -3 plus a -3x. This is slope-intercept form. Remember, whatever's being added on, even if it comes first, is our y-intercept. So in this case, my y-intercept is -3. Shouldn't be too surprised at that. Okay, and then my slope is the coefficient of x. And I can always put a 1 under it because that isn't changing the number. So from here, I could rise -3, so go down 3, 1, 2, 3, and then it's a +1, move to the right 1. And look right there. See how it's the same line? That's why it doesn't matter which method you choose. You're going to get the same line no matter what. Okay, so that's why for this one right here, instead of doing my intercepts, which I absolutely could do, I'm going to solve for y because there's no coefficient of y, so it's really just a one-step equation. I'm going to get rid of this -2x by adding 2x to each side. Notice that doesn't become a 4x. They're not like terms. -2x plus 2x is 0, so I'm just left with y equals 2 plus 2x. My y-intercept is 2. And my slope, rise over run, is the coefficient of x. So I'm going to rise 2 and run 1. Okay? So draw my line through there. Okay? And now we need to identify the ordered pair where the graphs of two linear equations intersect. And that occurs right here. It occurs at the point -1, 0. Because -1 is my x value, 0 is my y value. Okay, so we're looking at that as being our solution because it occurs on both lines, meaning it makes both lines, makes their equations true. Okay, so now let's verify it. Okay, let's prove it. Prove it. That's right. So I said that negative 1, 0 is a solution to this. So I'm going to plug in negative 1 for x and 0 for y and see if it works. 3 times negative 1 plus 0 does, that's supposed to be a question mark. We'll get there. Does that equal negative 3? Well, this adding of 0 doesn't do anything, and 3 times negative 1 is negative 3. So, yep, I'd say it works. How about this right here? Negative 2 times my x, which is a negative 1, plus my y, which is 0. Does that equal 2? Well, adding 0 on doesn't do anything. Negative 2 times a negative 2. Negative times a negative is a positive, and it works. So, could the point 1, 4 be a solution? Would it make both equations true? Well, remember, this is our x value and this is our y value. So, if I were to plot that ordered pair, 1, 4, ordered pair 1, 4, that occurs right here. So guess what? That is going to be a solution to my second equation here, but it's not going to be a solution to my first. No. Okay. How do I say that? Isn't a point on both lines. Okay, I know it's going to make this equation true, but it's not going to make this equation true. And I can show that real quick. Again, this is the x value, this is the y, and I'm going to plug it in. 3 times 1 plus 4. Does that equal negative 3? Well, that's 3 plus 4. That's equal to 7. That doesn't work. Okay, so even though it would make this equation true, okay, and I could prove that real quick, I could say negative 2 times 1 plus 4, does that equal 2? Just plug it into this equation. Well, is negative 2 plus 4, sorry, I threw that extra parenthesis in there. Negative 2 plus 4, that equals 2, so that checks. But to be a solution to a system, you can't just make one of the equations true, you have to make both of them true. And if you make both of them true on a graph, that point will occur on both lines.